Alright, so this video will cover information on Miller notations. Let's go through the conventions real quick that we have. So you have point, lines, family of lines, plane, and family of planes. For a point, you have x comma y comma z in parentheses. Remember that p for point, p for parentheses, but you have commas over here. For all the remainder of the elements, there will be no comma, right? So you have a line or a direction, square brackets UVW, the family of lines, caret brackets UVW, no comma. For a plane, again, P for plane, P for parentheses, you have parentheses HKL without any commas. For a family of planes, you have mustache brackets or curly brackets HKL. Let's do some quick examples for direction and line. So let's pick up the direction C over here. I'm gonna highlight it with this pink arrow. One thing that'll help you a lot with any notation when it comes to direction or lines is to remember this expression: final minus initial. Seems simple, but it's a very powerful tool to solve any equation. So what you have to do is you write the coordinates of the final point, you write the coordinates of the initial point and subtract them, and this is how you can get your final notation. Now when I say final minus initial, what I'm referring to is the tail and the head. So the tail is the initial, the head is the final. So the arrow starts from initial, goes to final. Okay. So if and this is the direction C in the picture. If you look, the first point, or the starting point, which is marked here, is nothing but half comma 0. It's sort of on the face center of this plane. On this plane. So the Z is, my bad. So the Z will be, let's redo this. So when it's on the center of this plane, you will have half in x, half in x, half in z, and then you have 1 in y, right? So the notation here, half in x, 1 in y, and then half in z. Now let's write down the final point. Final point is this point, this cross mark over here. That will just be 0, 0, 1 because it's on the z axis. So when you do the math here, this will become minus half, minus 1, half. And again, I still haven't written the Miller notation. So the final answer, you could write the final answer again in square brackets because it's a line. Line C will correspond to minus 0.5, or I should rather write it as bar 0.5. A minus sign is represented as a bar, and then bar 1, and then 0.5. And if you want to write it in reduced in integer form, you could also write this as bar 1, 2, or bar 2, and then 1. Both should be correct. Generally, writing it in integer form is easier to perceive and understand. All right, let's do another example. And again, remember, for a family or a direction, final minus initial will be the way to go about this system. Let's pick up the direction D. So this is the direction D, and again this will be your initial point, this will be your final point. So let's try to write down the final minus initial. So initial here, if you notice, it's 1/4 in the x direction, it has come 1 in the y direction, but 0 in the z direction, right? So again, the initial point is 1/4 in the x, 1 in the y, and 0 in the z. For the final point over here, it has come 1 in the x, half in the y, 0 in the y, and then half in the z. So this will be this will be 1 in the x, 0 in the y, and half in the z. And again, just do the math. 1 minus 1/4 will be 3/4 minus 1 half. So when you write this line D in Miller notation, again it's a square bracket, you could write this as 3/4 bar 1 half. And in the whole integer or the whole number form, this will become 3 bar 4 2. And this is the final line D that you have. And again, you can practice the line A and B directions here, right? Again, remember, final minus initial. Write down the coordinates of the final, write down the coordinates of the initial, subtract them, you'll get some final value, and then just write it in square brackets in whole numbers. And remember that negative signs, let's just write it down here. Negative signs are represented as bars or overhead bars to be more precise. Let's look at some plane notations now. Plane. So for example, in this figure, let's pick up the plane B. I'm gonna draw this plane B out, or highlight it at least a little bit. So this is the plane B given to us, right? When working with planes, this is the approach I suggest. First is find a good origin. You could just use generally the origin that is given to you. So for example, in this it is at the back here where the XYZ meet. Sometimes you don't have a good origin. By good, I mean an origin that can give you the intercepts. So your job is to find the x-intercept, the y-intercept, and the z-intercept. Once you find the intercept, the next step is to do reciprocal. Once you do the reciprocal, the next step is sort of reduction to the integers, and then writing it in parentheses. Again, P for plane, P for parentheses, right? No commas. So let's look at plane B for example. So in this plane, you can see that if you are at the given origin, which is over here, you will find that it will be a little bit hard to locate the z-intercept. So what I'll do is that I will move my origin to this point. So this will be my new origin. So we have found the good origin. Now let's look at the intercepts. So the intercepts would be, so let's write it, intercept, reciprocal, reduction. And we need x, y, and z, the three intercepts. So when you move the origin to this new point, let's redraw that. When we move the origin to this new point, this becomes your origin. Now this direction will be your positive x. From here, this will be your positive y. And then this direction now will be your positive z. So you have to find the intercepts based on these axes. So let's look at the x-intercept. If this direction is the x, therefore the one going in the back would be minus x. And you can see that it intercepts the minus x at the corner, which is the minus 1. Similarly, for y, it intercepts the y on this corner, which is again minus 1. For z, or positive z, it intercepts the z up here, which is the half, right? So let's write the intercepts for x, y, and z. For, I'm gonna get rid of the bars. For x, we saw it as -1. For y, again -1. For z, it was half. So after intercept, you do reciprocal, right? Again, remember the steps. Intercept, reciprocal reduction. This becomes -1, -1, 2. And you can see that it's all in the reduced form. And then when you write it in the parentheses, it will be bar 1, bar 1, and 2. So this will be your plane B, right? And here, again, remember the bar, which represents the negative sign. Let's try the same process for plane A. So let's erase this. The method still remains the same. Find a good origin, good enough that can give you intercepts, XYZ intercepts. Find the reciprocal of those intercepts, and then reduce them in whole numbers. Write them in parentheses without commas. So the plane here, A here, is a little bit tricky. Let's mark this out. Alright, so this is the plane A. Now, the origin that is given to us is again at the back in this corner, and we have the x-axis, the y-axis, and the z-axis. Let's try to locate the intercepts in this system. So with the x-axis, you will clearly see that it intercepts the x-axis over here, which is at the half. For the z-axis, you'll clearly see that it intercepts the positive z at 2/3, so 2/3. This is half. But for the y-axis, you'll notice that it is parallel, right? So mathematically speaking, two parallel lines meet at infinity. So you could write it in this way. So again, the x-intercept is half. The z-intercept was 2/3. The y-intercept, because it is, you can see that it nowhere touches the y. So it is parallel to the y-axis. Therefore, the x-intercept becomes half, y-intercept becomes infinity, the z-intercept becomes 2/3. And then you have to reciprocal this. So this will become 2. 1 over infinity is basically 0. So this will become 0. And 2 over 3 will become 3 over 2. And if you want to reduce it in a form, you could write it as 403. So your final answer will just become parentheses 403. And this will be your plane A. Right? So this is how you can solve planes and get the notations. Again, remember, get a good origin, which can give you the intercepts, the XYZ intercepts. Write down the intercepts, do the reciprocal, do the reduction, write the answer in parentheses without comma. I'm going to highlight it again. This will be without comma. And then the negative sign becomes an overhead bar. Overhead bar. All right. I would highly recommend using this sort of tabular form that I wrote. It helps at least me to not get wrong answers, and it makes things smoother and simpler to understand. And similarly, in an opposite fashion, we could try drawing the planes on a given cubic unit, on a given unit cell. It doesn't have to be cubic for our purposes. So for example, here you do not have a cubic unit cell. You have 3 different values. You have A, B, and C, and then you could have different angles. When trying to draw planes, so here let's say we have to draw the 110 plane, right? So we just do everything in reverse. So let's look at the analysis. So draw a plane, right? So you have been given a plane notation, Miller notation, something parentheses HKL. What we'll do now is we will take the opposite pathway. We'll do the reciprocal first, and that reciprocal will just give you the intercepts, right? So for example, the first one, which is 110, so the first one is given to us as 110. You do the reciprocal, it looks like this. Therefore, these will be the intercepts. So the intercepts are 1, 1, and infinity. So it intersects the x-axis at 1. It intercepts the y-axis at 1. And it's parallel to the z-axis. So the plane 110 will look something like this. And you'll notice that it is parallel to the z-axis. Right? Similarly, let's do the second one, bar 1, 2, 3. So again, use this formulation bar 1, 2, 3. Do the reciprocal first, okay? So reciprocation will give you -1, 1 over 2, 1 over 3. And that just becomes your intercept. So what I'm saying is that the x-intercept will be -1, the y-intercept will be half, the z-intercept will be 1/3. So let's try to draw that out. If the x-intercept is -1, it will be sort of on the back side. So let's extend the x-axis in the -x direction. And this will be approximately -1 point. And then you have half and 1/3. So the y half will be somewhere over here or a bit more in the center. The z will be somewhere over here. So your plane will just be this. Again, remember, this will be half, this will be 1/3, and this will be 1. So this will become your plane. Let's do the last one real quick. Same procedure. The procedure still remains the same and always works. That's a good point. This is bar 1, 1, and 1 in parentheses as the plane. Let's do the reciprocal. It just stays just like that. And -1, 1, and 1 are the x, y, and z intercepts respectively. So again, let's extend the x-axis in the negative direction. Let's mark the -1 intercept. For the y, it's 1. For z, it's 1. So you just have to connect these points. I can make it a bit more obvious so that it's easy to understand. But yeah, this is what you will get as the bar 1, 1 plane. And you can practice doing more planes and drawing out more planes in non-cubic systems. Again, remember, this was a non-cubic system. That doesn't matter to us. Everything still remains the same. And same goes for writing indices. So let's say this was a non-cubic system. It's some other crystal system. Doesn't matter. Our approach will still remain the same. And similarly, you can write the Miller notations for these planes over here using the same approach that we did earlier. Find a good origin, good enough to give you intercepts. Once you have the intercept, reciprocal or reciprocate those intercepts, and then reduce them to whole numbers. Once you have done all this, whatever the final values are, express them in parentheses without comma. And in HKL form, that'll give you the plane notations. I highly recommend practicing more planes if you think you need more help with this. The example problems in the homework have some good options to practice with. do keep these conventions in mind. Thank you.